So 2.5, model direct variation. So for these first ones, it says to write and graph a direct variation equation that has the given ordered pair as a solution. So number 4, we're given the ordered pair -3, 12. So first of all, what we're going to do is we're going to plug those numbers into that y equals ax equation for x and y and figure out what a is. And then we have to rewrite the equation with a in it. So y equals whatever that a value is times x. So we're going to have 12 equals a times -3. So then -4 is equal to a. And then our equation rewritten would be y equals -4x. So that would be your direct variation equation. And then it wants us to graph it. So, what's my y-intercept? 0. And then my slope is -4, so I'm going down 4, right 1. Or up 4, back 1. Let's see, another one of these, number 8, the order pair 24 and -8. So what am I starting with? -8 equals a times 24. So then to get a by itself, dividing by 24, it's going to reduce down to -1/3. So then what's my direct variation equation?
Y equals
-1/3 x. And then we need to graph it. So I've got y-intercept of 0. And then I've got a negative slope, so down 1, right 3. Some in my throat. Or up 1, back 3. So then the next ones say that the variables x and y vary directly. Write an equation that relates x and y, and then find y when x equals 12. So we're going to start out the same way, and then we're going to plug in 12 for x and solve for y. So number 12, we are given the x equals -3 and y equals -5. So I'm going to start out, I need to find a. So negative 5 equals a times negative 3. So a is going to be equal to 5 over 3. So then I write the equation y equals 5 over 3 times x. Now this is part 1 of the question. Okay, part 2 says what happens when x is equal to 12. So I'm going to plug in y equals 5 over 3 times 12. So what is y? 20. And this is part 2 of the problem. Let's see. Another one like that. Number 16. X is equal to 2/3 and y is equal to negative 10. So how do I start it?
Negative 10 is equal to 2/3 x. 2/3 a.
Yeah. And order doesn't matter on that side. Alright, so then we need to multiply by 3, divide by 2. So that's going to give us negative 15 is equal to a. So my direct variation equation is what?
Y equals negative 15x.
Yep. And then I need to solve it for x equal to 12. So y equals negative 15 times 12. What is that?
Negative 180.
Negative 180. Let's see. Tell whether the equation represents direct variation. If so, give the constant of variation. Okay. So, number 18. Y equals negative 8x. Is this direct variation?
Yeah.
Okay. And then what is the constant of variation?
Negative 8.
Okay, so I just do dv for direct variation. If it's not direct variation, you can just do not dv. And then constant of variation is, I just did COV, is negative 8. How about number 20? 3y minus 7 equals 10x. No. Okay. We need to technically, just because it doesn't look like it initially, we do need to like move stuff to verify that it's not. So 3y equals 10x plus 7, and then y equals 10 over 3 x plus 7 over 3. So then as soon as you see this right here, this plus something, it cannot be direct variation. And then 22, 5y equals negative 4x. Would this be direct variation?
Yes.
Okay, so we divide by 5, so y equals negative 4 over 5 times x. So it is direct variation, and what's the constant of variation?
Negative 4 over 5.
Yep. I tried to do a few of those because this is like the problems that I was telling Riley yesterday because she asked what she was going to be missing. Oh, hi, Riley. But it's a section that's not hard, but it's the one that I see the most mistakes made in this chapter very specifically. But it's like, people are like, oh my goodness, like there's another number. It's not blah, 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 or it doesn't look like it's in the right form to start with. It's like, it's not so much where it starts, it's where it ends. So, so I try to do several different ones of those ones. So just like number 12 and 16, we're doing the same thing, but now they want us to find x when y equals -4. So we're going to do the same thing there. So number 26, x is -18, y is -2. So how do I start?
-2 equals a times -18.
So that means a is going to be 1/9. So my direct variation equation is what?
Y equals 1/9 x.
Y equals 1/9 x. So that's part 1. Part 2 wants it when y equals -4. So this time we're going to plug in -4 instead. So -4 equals 1/9 times x. So then x is equal to -36. Let's see. All right, so these next ones give you a table. So it's an x and y table. And they put values in here. And they want to know if it is direct variation or not. So, basically what we're going to do is we're going to group these as like individual ordered pairs, and we're going to check and see what happens when we use them. So, and I would say, unless it's pretty obvious, like one way or the other, I would check at least 2 of them and see, because they should all be the same if it's direct variation. So if you checked like 1,7 and then we checked 4,13, like it should be the same a value for both. So we're going to plug this in. So 7 equals a times 1. So that means a is equal to 7. If we checked it for, let's just do 2,9 because it's the next one. If we checked it for 2,9, then we would have 9 equals a times 2, which means that a is equal to 4.5. Since those are not the same, this is not direct variation. So then let's look at one more of these. Alright, so I've got -8 and 8, and then I'll check -4 for. So I have 8 equals a times -8. So a equals -1. Then I've got, for the other one, 4 equals a times -4. So a equals -1. So those are the same. So if a is -1, what would my direct variation equation be?
Y equals negative, or just negative x.
Yep, y equals -x, and this is direct variation. Any questions about those ones? And sometimes this is how they like solve the word problems too. Just different things that they do. Like we don't really do a lot with that, but just FYI. Alright, so then your problems are 3, 11, 13, 19, 21, 25, and 33.